Hello, today I am going to discuss with you about the basic introduction of Zener Diode. What is Zener Diode? If you look at the symbol of this Zener Diode as shown here, you will notice that the symbol is not much different from the standard normal diode. The only difference is the small horizontal line located here and here. So for normal standard diode, when it is connected in forward bias manner, meaning the anode connected to the positive side and the cathode connected to the negative side of the DC power supply, it will conduct the current, and the current will flow through the circuit via the diode. Similarly, for the Zener diode, when we connected it in a forward bias manner, which is anode connected to the positive side, cathode connected to the negative side of this DC power supply, it will conduct a current in the circuit. However, we usually connect Zener diode in a reverse bias manner, meaning we will connect the anode to the negative side and the cathode to the positive side of the DC power supply. Zener diode is usually used to regulate output voltage and also for overvoltage protection. In AC circuit, it is used to clip the voltage. Zener diode got its breakdown voltage, or sometimes we call it Zener voltage. In this case, it's 10 volt. So when we connect this Zener diode in a reverse manner, and the DC power supply voltage is more than this breakdown voltage, it will conduct a current through the Zener diode. Let's demonstrate here so that we can understand further. Now, the Zener diode is connected in a forward bias manner. So, when we close the circuit, the current will flow through, just like a normal standard diode. Okay, let's demo. Okay, so you can see the current flow through the circuit, and this is a lamp. It lights up when the current flow through the lamp. So what happened? Let's say I connect the Zener diode in a reverse manner. Let's off the switch. Okay. Then turn on the switch and you will see, let's say the DC power supply voltage is maybe 8 volt. What will happen? The current will not flow through the circuit. Why? Because Zener diode is connected in a reverse bias manner. So in order to flow the current through this Zener diode, which is connected in a reverse bias manner, the DC power supply voltage must be more than this breakdown voltage. For example, I increase the DC power supply to about maybe 12, about maybe okay, about 14 volt. What will happen? This DC power supply voltage is more than this breakdown voltage, so the current can flow through the circuit. If you measure the voltage across a Zener diode, you will notice the voltage is always maintained at around 10 volt. What happens if I increase the voltage to 20 volt? You can see the voltage across the Zener diode is also about 10 volt. So no matter how high the voltage of the DC power supply, the voltage across the Zener diode will remain at 10 volt. That is why Zener diode is usually used to provide constant or to regulate the output voltage. So if the Zener diode breakdown voltage is 20 volt, it will always maintain at 20 volt, and so on. So that's it. Thank you.